in this video, we are going to go over the 2 Ohms law packets. All right, there's the 2 Ohms law packets that I sent home. Plus, you should have the Ohms law circle, and you really are going to need that scientific calculator app that I talked about on the Teams chat page. I think it was called Hyper Scientific. So if you guys get that really any of those calculator apps will work, as long as they're scientific calculators, you know, the ones we're used to using. There are quite a few good ones out there. So with your cell phones, you should be able to handle this. Again, the most challenging part of this isn't the math. It's not the multiplying and dividing. That's easy. The fact is, in what people screw up are the prefixes again. All right, I don't mean to insult you guys. I know we've been over this. I know you've used Ohm's law a million times, but putting this video out there because there are some people that might forget. So, if you have this paper in front of you, just remember, if they're side by side like this, like I squared times R, that's multiplying, right? E squared divided by R, right? E divided by R. That gets, this whole section here gives you current. So this is a current. Section here, these are all how you calculate powers. All right. Obviously, this section here, these 3 are all the different ways to find voltages. And finally, those are all you can use for resistance. Do you have to do it that way? No. You can always just go back to what we've used. The Ohm's law circle and the Watt's law circle, and do it in 2 steps. Okay, so you can do that. That works as well, no problem. Okay, so let's do a couple of these. Again, the prefixes are probably the most challenging part of this. So looking at this first paper, and this one's kind of easy, okay, we have a current, we have a resistance. We have 5 amps, we have 10 ohms. So if you have those 2 values, you can find either voltage or power. But if you go back to using just the 2 circles, then if you have current resistance, the easiest thing to find is voltage, right? So you have 5 amps and 10 ohms. So if you do 5 times 10, you're going to get 50 volts, right? Okay, so once you have your 50 volts, that's the missing piece that you need to find power. Okay, so we're trying to find power. P equals I times E. So you got 50 times 5. What's 50 times 5? 5 times 5 is 25. Put 0 on it. You got 250 watts. There's those prefix things again. So, looking at this one, you have power and you have current. This is number 5. You got power and you got current. 200 milliwatts, 200 milliamps. Okay. Well, being they're both milli, let's just ignore the millis. So if you do P divided by I gives you E, that's 200 divided by 200, right? You're going to get 1 volt there. Okay, might have to use a calculator. Might have to. We need resistance. How do you get resistance? You do E divided by I. Okay, so if you do 1 volt divided by 200 milliamps, or 1 volt divided by 0.2, let's see if my calculator will work here. 1 divided by 0.2 equals, I don't know if that shows up or not. It might. Looks like it. 5 ohms. So that's number 5. Oh, let's do number 6. It says we got 12 volts. Your resistance is only 0.01 ohms. So how do you get a current? You do E divided by R, right? E divided by R. You can't do R divided by E. Okay, every year I get people that will go through and do the test for this. They'll reverse these 2 and get the wrong answer. It's E divided by R. You got to put these in the calculator the right way. So let's try this. Oh, I wish these calculators worked better in this low light, which is the only way I can film. So if we do 12 divided by 0.01 equals, if you can get that, 1200 ohms. Excuse me, 1200 amps. Wow, that's a big one. That sounds huge. Kind of unrealistic, actually. 1200 amps. Okay. Out of a 12-volt power source. I guess it's possible with the car battery. It'd be a short. Pretty much a short. You'd probably have an explosion with that kind of current. That's why when I looked at it, I was like, "Ooh, that must be a resistance," and I forgot what we were doing. Okay, so what kind of power is that? Power equals voltage times current. So we need to just multiply these. It's going to be a big number. So take your 1200, just multiply it by 12. Ooh, right there. See if we can get that in the camera. 14,400 watts. Or, what's the other way of saying that? 14.4 kilowatts, right? Number 7. I know you guys have seen this one before because it was on the test. How do we do that one? We don't know power, we don't know current, we don't know resistance. What do we do about it? Can't do anything with it. Okay? You have 120 volts and you don't have it hooked up to anything that's drawing current, you don't have it hooked to any resistance, there's no power. They're basically not applicable. Nothing you can do. You always have to have 2 variables in order to do this. Okay, let's find something with some more radical prefixes here. Maybe on page, well, that one there is probably not bad. Let's go down. We'll do 16 and 20. How does that sound? Hopefully that's in the camera angle. Looks like it is. Boy, that was a scary shot in my face. Anyway, all right, so number 16. It says we have a voltage of 9 volts. We're drawing 0.75 amps, 750 milliamps, right? So how do you get a resistance? E divided by I gives you R. So if we go through, and if it's in the calculator, or in the camera here, 9 divided by 0.75 equals, can't see myself, looks like it says 12. Okay, so we took E divided by I, this is 12 ohms. All right, 12 ohms. Okay, we need power. How do you get power? P equals I times Z. So if you still can get the thing to work, 9 times 0.75 equals, can you see that? Looks like it. 6.75 watts. Actually, you know what? This one's got micro and milli in it. Let's do those, because I know that's always the problem, is these prefixes. So if we have 50 microvolts, 50 milliamps, we need to multiply to get power, right? P equals I times Z. So let's put it in this way. We can see this. We're going to put 50. Remember, that's the EXP button. Whoop, right down there, EXP button. Exponent. And micro is -6. So you're going to hit -6. Okay, can you see that? 50 micro. There's your 50 microvolts. We're going to multiply that by 50. Hope that's showing up. Exponent -3 for milli. I think that's in there. Okay, hit equals. Can't even see what it says. You got to remember, everything I'm looking at in the camera is backwards. I have to hold it out here. Okay, that says 2.5 exponent -6, right? 2.5 exponent -6. So that's 2.5 micro. So being we multiplied these, that is 2.5 micro watts. Okay? So now, in order to get a resistance, we need to divide. So E divided by I gives you R. Okay, so again, the trickiest part of that is getting these put in. So again, we're going to put 50. Oop, there we go. 50 exponent negative 6. All right. Divided by 50 exponent negative 3. We got that. Everybody good with that? Everybody's good with that? We'll hit equals. Oh, light. I think I can see that backwards. Yeah, 1 milli. Wow. 1 exponent negative 3. So 1 exponent negative 3 is 1 milli ohms. So E, yep, we did it right. E divided by I, 1 milliohm. Very small resistance. Well, look at it. We got a very, very tiny voltage, and it's pushing a very tiny current. Okay? So something's going on here. Very, very, very small resistance. Let's just take a look here real quick at the second sheet. See if there's anything I see that looks radically confusing. How about we do number 5 here? We'll do number 5. Again, it's the prefixes. So if we have P and an E, we can find an I. Right? Power divided by voltage, give you current. So if I do 10 milliwatts, come on, turn on. 10 exponent negative 3 divided by 40 exponent negative 6. Ooh, that's quite a bit. Make sure I put that in right. Yep, 10 milli divided by 40 micro. God, that's 250 amps. You can see that, right? Okay, so what is my resistance? So now if I do E divided by I, we'll get R. So again, we're going to put 40, showing up right, 40 exponent, negative 6, divided by, that's my voltage, voltage divided by current, 250. Uh-oh, there's exactly what I wanted to happen. What's that weird, whoa, what kind of answer is that? It says 1.6 to the negative 7th. We don't use negative 7 here in electronics. So this is one of those you're going to have to hit that ENG button. All right, so when we hit the ENG button, what'd that do to it? Turned it into nanoamps. So our answer is 160 nanoamps. Ohms. Ohms. More worried about the nano. Forgot which one I was working on. Okay, so 160 nano ohms. Let's do another one. Let's see here. I'm trying to pick the crazy ones, the ones that the answers are a little weird on. Let's do 14. We're on page 2 of the Ohm's Law, number 14. So it says right here, power is 28 milliwatts. Our voltage is 56 volts. Okay? So we're going to, again, with the calculator, we're going to put 28. If you see how dirty my hands are, it's not dirt, I'm painting. Just so you know, I've been painting. 28, squirrel, yeah. Exponent negative 3. Okay, there's my 28 milliwatts. We're going to divide that by 56 volts. Uh-oh, there we go again. Ah, what is 5 to the negative 4 power? Remember, we don't use negative 4. Okay, so you're going to hit that ENG button. What'd that do? If I had light, it would work. It gives us 500 microamps. Okay? 500 exponent negative 6, 500 microamps. Okay, now I need resistance. E divided by I gives you R. So now we're going to do 56 divided by 500 micro. So, 56 divided by 500 Micro is exponent -6, right? Okay, equals, what do we get? Pretty big resistance. Ah, I can read it. Looks like it says 112,000 ohms. 112,000 ohms. So let's write that in kilo. Okay, I hope that got people kind of back into the motion of using the exponent button, the engineering button on the calculator. Remember, those can be your best friends. I use the same app. I think it's the Hyper Scientific app. Yeah, that's what it says, Hyper Scientific, which in turn, oh, I'm getting emails. So the Hyper Scientific app works well for this. I'm trying to keep it tipped. It looks just like our calculator. Also has the, you can move the decimals around and everything with it. So that's not a bad. There are others out there. So that's Ohm's law. Maybe I'll redo this video. I don't know. So we'll see how it looks. But again, if you have any questions, ask me on Microsoft Teams. And hopefully we can figure out the video conference chat part of it. I'm hoping we can use these YouTube videos. I'm hoping they will work in place of that, just because with this, you can go back over the stuff if there's something you didn't get, and say, how did he do that? Oh, he's holding the calculator up there and you can see it. So, all right. Talk to you guys later.